Hey, it's Mr. Allred, and we're here to talk about analyzing data. And we're going to start off with our good friends mean, median, and mode. A lot of people are familiar with these, but the mean, sometimes denoted in our book and in lectures as X with a little bar over it, means average. Most people have already experienced mean before, so it's just the average. Sorry, I'm a little sloppy there. But that means add all items together. And divide by the number of items. Just like you would find any average out there. So that's one way to talk about a central point or estimate a central point. The next is the median, which is the middle of a data set, but you need to put all data in order and find the middle term. That means if you had 9 items, you would pick the one in the center, as we'll see in an example. It's worth noting if there are an even number of items, let's clean it up just a little bit, an even number of items, average the middle two. Running out of room there. So the mean means to add them all up and divide by how many they are, just like you would average your grade. The median means to put them all in order, and that means numerical order, and pick the one in the center of the list. And if there happens to be an even number, that means there's 2 things in the center, so you can average those out. Okay. The last one, mode, is the most frequent. And it's possible to have no mode if nothing is repeated. There's something called unimodal, which means there's 1. Bimodal, sometimes 2 items appear the same frequency. And then there's also multimodal. Let me leave a little room there. Multimodal, meaning you have several modes. So unimodal means 1, bimodal means 2, no mode means 0, of course, and multimodal means more than 2 or many. So all 3 of these things are useful in different scenarios that we'll get to in a following video, but we're just going to go ahead and calculate a few things from a data set below here. So here we're given a data set and asked to find the mean, median, and mode, and we have several numbers. We have 16, 44, 15, 48, 14, 77, 11, 84, 26, 61, 15. We don't have to put them in order for the mean, but I'm going to go ahead and put them in order since that's going to be the main objective in doing some of this. Looks like the smallest number is 11. Then the next one is 14. Then I see 2 15s and a 16. So right now we're working with mainly small numbers. But then the next number I see is 26. If I'm not missing anything, 44, then 48. Then 61, 77, and 84. So it's easy to miss things, so let's count both lists here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 things here. That's good. So first of all, the mean is the average. Okay. So I'm going to add all those up. So I'm going to pull out my calculator and I'm going to add all 11 numbers together and divide by 11. So here I am adding them up. And I get a total of 411. I'll write that down just to make sure we're on par. We'll divide by 11. I'm going to round this to 2 decimal places, so it's approximately 37.36. If you notice, most of my numbers, at least more than half of them, are less than that number. So they could be split up a little bit differently. Let's see here. The next thing is the median. And since we said there were 11 things here, we should be able to find one in the middle. So I'm just going to kind of count off one on each side. So I'm going to take the 11 and the 84 out, 1477 out, 1561 out, 1548, 1644. So the one that's left in the middle is 26, which is very different than our 37 if you think about the data set. And the mode. So we look through here, 15 appears twice, and that's it. So appearing twice is enough. So 15 is the only mode. If we need to, we could say that's unimodal. There was only one mode there. But that's what we're doing. Mean is the average. Add them up, divide by how many there are. Median, it needs to be in order, so we can find the middle. Mode, it helps to put them in order so you can see like things grouped together. So with these all mixed up, you might miss the 15. Okay. All right. So we're going to do some more of that in the following example, but let's talk about a few things here. Of the 3 averages, mean, median, and mode, the mean should be used with data consisting of numbers. And measurements when the data doesn't include any outliers. So an outlier is something that is very different than all your other data. So let's say we took the age of all NBA players and we randomly found one that was 45 years old. That's kind of an outlier. That's pretty far from normal. But an outlier is a data value that kind of messes up the average because it's so far out of whack. If you had a county and you had like a billionaire living there, but it was kind of a poor county, the billionaire would really mess up the average income or the average worth of a person and kind of give a very false representation. So sometimes lining everything up and picking the middle value or seeing what's the most frequent would make more sense. Okay. Here we're going to try and go through this rather quickly. I might have to pause the video to make sure we don't run out of time. But 2 other things we need to talk about. The range. The range is the largest value minus the smallest value. So it just kind of tells you the spread of your data. And a standard deviation, that is a measure of how spread out the data is. So the range will tell you, the biggest to the smallest, and it can tell you that's what your data covers. But the standard deviation goes a little bit further and it says, well, you may have a really wide difference between the biggest and smallest value, but maybe everything is kind of clumped toward one end. So it will kind of tell you how normal it is for things to be spread out. And I have the formula here for a standard deviation, and it's a little doozy, but we're going to talk about it and actually work through it in the table below here. So we're going to calculate the range and the standard deviation, and we're going to use the table for that. But we have the numbers 17, 21, 18, 18, 24, 19, 21, 20, 28. I can look through here and I can find my biggest number, which appears to be 28, and my smallest number appears to be 17. It wasn't intentional to put them at the front and the end, but the range would be 28 minus 17, which is 11. Now, one thing as far as find the standard deviation you're going to see up here in that formula is you're going to have that x bar, which is the mean. So we're going to find that. So the mean, which is x bar, we need to add these things up and divide by how many there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. Okay, so we're going to add them up real quick. And I get the average is about 20.7. Okay. So what I'm going to do is I'm going to come down here and start working on this table, which kind of makes that formula happen. I'm going to list all my data points on the side here, and I'm going to pause the table while I do that and kind of do a couple calculations to save some time. So I'm going to do some things and then talk about them. Okay, I've done some quick calculations here. But talking about the standard deviation formula here, in here you see x. That's our list of numbers here, 17 to 28, minus x bar, which is minus the mean, which I have down here in the table. I've taken all these numbers in the list and subtracted 20.7, which you'll see the whole table in a second. And then that value gets squared. So you might see some negatives when we subtract, but when we square, they're all positive. Okay. And then this thing over here, this weird little symbol is going to mean to add them all up. So let me show you the table. You can pause the video and do this on your own and kind of catch up. But I listed all the x values, all the data points I had over here. I subtracted the average, 20.7 from all of them. And then I squared all those values. And then I've added them up at the bottom and get 96.01. So we're almost there. So then we have the rest of the formula, which is going to be the square root of 96.01, and it's going to be divided by n, where n is the sample size, which was 9 items. So 9 minus 1. So we're going to have 96.01 divided by 8. We're going to take the square root of that. Okay. So let's do that in our calculator. 96.01 divided by 8 gives me 12 something, and the square root of that is, just kind of following up here, I got the square root of 12, which is about 3.46. So that's kind of a measure telling me how spread out this data is here, this little list. So for numbers that are more spread out for a larger range, we would have a bigger standard deviation. If we had numbers a lot closer together, we'd have a smaller standard deviation. So an average can tell you how big numbers are, but a standard deviation will tell you if they're really spread out. So you can have really big numbers that are really close together. So they're just basically all about the same number. So let's have a small standard deviation. Or you can have really big numbers and they'd be really spread out and have a big standard deviation. But just to kind of review in the closing seconds here, we took all the data points we had, all the values, we subtracted the mean. So here we're subtracting 20.7 from every one of these guys individually. We squared them all and added up to get a total. Then we divided by 1 less than the number of items there was and took a square root. Okay, just kind of go through those steps and practice. You'll see another example in the next video.